Hello everyone, Principal AI has started this new video series focused on giving you in-depth understanding of system design for AI-based systems. These days, a lot of companies are questioning candidates about their ability to design AI-first systems. We plan to give you a very comprehensive overview of designing such systems. Please subscribe to our channel and like this video to show support and to be notified of future videos. In today's video, we are going to give you a very high-level overview of how a typical AI-first system may be designed with its primary building block being an LLM inference service. A business such as an e-commerce website or a bank might have an existing IT system. It now wants to use LLMs to power various business processes. How do they go about doing this? Of course, ultimately, product decision matters a lot, but the core building blocks of the system should be reusable across the org. Typical AI solutions that an organization might think of using can be classified as conversational or interactive solutions, where an end user or even an employee might interact in a turn-based chat-like interface. AI can also be used to give a more personalized experience to the user by recommending specific actions or rearranging their attention. Example of this could be to show user a set of products on home page based on their purchase history. Internal employees might also use the AI to extract insights, and leadership might want to use AI to make better and smarter decisions. Another area of assistance could be to summarize or present data to the users in a shorter and easier to understand format. For example, an AI might tell user a short summary of how their credit card bill history looks like. Irrespective of what is user use case, the core building block of an LLM-based product would be the model itself. A model is nothing but a static list of numbers. It is pretty large and runs on specialized hardware, and it does not change. A small model with around 7 billion parameters can fit in around 24 GB VRAM, but larger models might need even more resources. Interface to a model will vary based on type of model. If you're using something like Google's Gemini model, it might be available to you only as an API. However, you can run Llama and other models on your own hardware too. Choosing which model to use is a complex decision in itself, and it is also possible to use multiple models for different use cases. Deploying models would be a separate topic, but the most used aspect of this system would the inferencing service. Inferencing a process where we give model a question and expect an answer from it. An inferencing microservice is responsible for this and is exposed as a REST service to all the consumers of our organization. REST is just one of the technologies. We can also use something like gRPC, but this will be the basic building block of our system. We will see now why this might be inadequate, but we should treat LLM or our AI model as a separate black box service which is then used by rest of the organization. This is because models are expensive to train and run. They need specialized and expensive infrastructure. We do not want multiple teams to own this. This makes our DevOps simpler. Also, we might want to enforce uniform safety standards and might have compliance and legal requirements which are easier for us to manage if they are centralized. To give you context, a small model with 7 billion parameters needs around 24 GB of memory. Anything larger would need even larger memory and complex hardware for inference. You do not want multiple teams owning or managing interface to that. It is better to have specialized teams managing and optimizing these resources and also rate limit the resources. Now, every prompt that you give to the model is stateless, which means the model has no context of what was asked previously. In many cases, however, you want the model to remember what was asked before, and you need to introduce a concept of session. It is best if our service also manages the session too. This way, conversation-based queries can happen more efficiently. That is why we introduce session persistence layer. Any consumer service will first issue a request to start a session. It will return a session ID. Subsequent methods would pass this session ID so the LLM service can understand the full context of the query. In the end, the session can be closed by the consumer service. Models are evolving, and we need a good handle on how they are performing in the wild. We might want to fine tune, deploy new models, etc. We might want to build dashboards to understand precision and recall. In order to do all this, we want to log all the requests and responses, process them, and put them into databases where they can be queried pretty fast. That is why we add a logging queue. It is a message queue where our system can write events and we can create an ETL pipeline to process these logs. Now we come to the next important component. A lot of prompts might need access to external data. This could be a document, a CSV file, database, or even images or videos. Using LLMs to generate content using an external source as input is called RAG. RAG stands for Retrieve, Augment, and Generation. It might sound complex, but in reality consists of very simple steps. A data source is given to LLM. LLM extract relevant information from it. This is called retrieve step. Then the model uses its own knowledge augment that retrieved information. This is the augment step. In the final step, the LLM can generate the output. This is the generate step of RAG. Another thing to remember here is that data for RAG is stored not in the raw format, but is converted into what is called an embedding. This is numerical format that the model understands. It also saves space. LLM inferencing service would need access to this data as well. To conclude, we have shown you a very simplistic and high-level design of an LLM-powered AI system for any technical project. We have kept it deliberately simple to give you a better understanding of the high-level design. In subsequent videos, we will take more specific use cases, look at low-level APIs, and other challenges. Please subscribe to our channel if you want to learn more. Leave a comment if you have specific questions. We have a premium subscription too.